welcome. Thanks for joining us. I'm Mark Hannon from the City of Charles Sturt, your host for today, and we're excited to bring you this series of webinars that we've called Bite-Sized Bees, and it's been presented by Sandra Ulrich of Adelaide Bee Sanctuary. We've worked with Sandra and Adelaide Bee Sanctuary in partnership for the last 5 years, and we host a number of their beehives across our community gardens and community centres. Now, this is our second foray into online webinars, so hopefully all goes smoothly and you love what we do and what we have to share with you. So bear with us, we're not professional TV presenters or in a professional TV studio, we're in the COVID studios, so we're doing our best. Also too, if you're not used to Zoom or you've never done Zoom before, I encourage you to get comfortable with adjusting your on-screen controls. Play around with your own screen display sizes. You can make the presenting window bigger, or you can make the presentation bigger, make me smaller, use gallery view or speaker view. Basically have a go and make it work for you. Today, we bring you episode 2 of Bite-Sized Bees. We find out how bees spread across the globe, the meaning of swarming, and all about the scout bee. We'd love for you to ask lots of questions in the Q&A chat panel, and we'll get Sandra to answer them at the end of her presentation. I'll come back for that segment after that to manage all the Q&A. So lots of questions, and if we have lots come through, we'll try and pick the best ones. Now, it gives me great pleasure to hand over to Sandra for episode 2 of Bite-Sized Bees. Enjoy, and now watch me hopefully seamlessly fade to black as we bring up Sandra's presentation, which I'm hoping I can do a little bit more smoothly than I tried to just now.
Hi, everybody. Welcome to the second episode of Bite-Sized Bees. My name's Sandra Ulrich, and previously we've looked at the evolution of the social honeybee and the commonly known branches of the genus Apis, or bee. So I presented about Apis mellifera, or the Western and European honeybee, and Apis cerana, the Eastern or Asiatic honeybee. And we looked at their sensory world and the wax-building world of these bees. Today I'll briefly present the distribution of bees across the world and look how the process of swarming enabled the honeybee to be such amazing survivors. So what's so amazing about the Western or European honeybee is the extent of their reach into temperate Asia and Europe. Okay, they were able to do this because they developed the ability to survive cold winters by forming a cluster within a shelter of a nest cavity. So the European honeybee or Western honeybee developed during the evolutionary period as a result of geographical isolation caused by the barriers of sea, desert and high mountain ranges, and also by barriers caused by changes in climate during the Ice Age. So each successive extension of the polar ice sheet locked up much of the water as ice, so the sea level fell. This created many land bridges between some continents and allowed animals, including man and bees, to pass to new regions. A number of different ecotypes of bees evolved and prospered in different climatic regions within Europe. And so the image that you see here shows the distribution of Apis mellifera, the Western honeybee. And there are many recognised subspecies and races and ecotypes of this honeybee, and they vary slightly in body size. And there was also a mixing of races as they were also transported across Europe. So, for example, in Anatolia, the high central plateau of Turkey, the bees there are very hardy, whereas in the Sahara, the Atlas Mountains and the west of North Africa, the bees are quite frugal and hardy. In the previous sessions, I also mentioned that honeybees were able to survive by being able to produce wax, build multiple combs, so not a single comb, but multiple combs, and regulate hive temperature by raising their body temperature to 45 degrees Celsius. But the survival and distribution of honeybees is also tied into the natural reproductive tendencies of colonies. And by colony, I mean a group of bees, 20 to 30,000 with one queen. And this process is called swarming. And I'm sure that we're all aware around springtime when the honeybees are on the move, and we end up with a swarm in our garden. So let's talk about swarming. This image here was taken at Blackside. Huge swarm in a gentleman's backyard, beautiful bees, and they currently reside in Montacute in the hills there. Swarming involves a number of processes that occur within the hive in order for a colony to divide or reproduce. It starts in spring or sort of late, certainly here, late August, and can go all the way through till May. And each colony has much to accomplish in order to survive the following winter. At this time, as a resident, it's important for you to make sure that any air vents and cavities are closed in and around your house. This will prevent bees from taking up residence in your wall cavity, and the need to euthanize bees is minimised. So the first step for a colony is to prepare for swarming, and this requires the rearing of 10 queens. Okay, so the bees decide to make their queens. The bees, worker bees, female bees, don't automatically become queens. They choose an egg, or eggs in this case, 10 eggs, laid by a queen, and they will make their queen. So this is the first step, and the reasons for swarming are not fully understood, but suggestions also include congestion of adult bees, a lot of immature bees, and the expanding food resources. So we've got 10 queens, for example, that are developing in their cells. And this is rapid and takes only about 16 days. Whilst these daughter queens are developing, the reigning queen is still walking around the inside of the hive. Worker bees have decided to make another 10 daughter queens or princesses. The reigning queen, the older queen, undergoes huge changes in her physical form that will prepare her for departure. She's quite large and she's quite voluptuous and reasonably heavy, so she needs to be able to fly. So the worker bees who tend to her feed her less and less. Her egg production declines and her abdomen shrinks quite dramatically. Worker bees also start showing some mild hostility towards her. Okay, they start shaking her, pushing her, and lightly biting her. And these bouts of mild hostility become continuous and force the queen to walk around the nest. This exercise, reduced feeding, results in a 25% reduction of the queen's body weight, resulting in a lean, mean flying machine, so to speak, ready for flying. I just came up with that. Anyway, so she's ready to go, but she can't leave the hive by herself. When you see a swarm, as you see in the image here, there are lots and lots of bees there to support her. She needs thousands of workers, about 2/3 of the colony, to leave with her, because she needs a workforce, okay, to tend to her, to take care of her. She doesn't feed herself or groom herself. They do that. To help care for the young, she'll be laying eggs, so we need nurse bees, and prepare the environment for the new nest. So the queen cannot survive without her worker bees. Prior to leaving the hive, thousands of worker bees stuff themselves, gorge themselves on honey. So think of yourself after a big meal, big belly, they've filled themselves up, causing their abdomens to swell and increase their body weight by 50%. Okay? And when a swarm, which is made of one queen and thousands of worker bees, leaves on their journey to the new home, approximately 1/3 of its weight is as food reserve, which is honey. And we also know that the wax glands, in the previous episode, I spoke about how wax are produced from the wax glands in the abdomen of the bees. They also become enlarged in readiness for the wax secretion, which is needed to build the new comb at the new nesting site. So I've got the word ready here. Now, this is the really exciting bit. The most striking thing for a beekeeper, when I see bees and I think, okay, what's happening here, is that they generally demonstrate greater lethargy before swarming takes place. Many hang quietly on the comb where I take out the frames, while others rest in a thick cluster outside of the hive. And this is where the amazing scout bee becomes the champion of the swarming process, because they're the ones that are qualified to lead this mass exodus of about 10 to 20,000 bees and a queen. So there are approximately 100 scout bees Okay, they've spent time both inside and outside the hive, and they also can get the timing right for swarming. They don't want to leave on a stormy day. They certainly don't want to leave on a day like today. Okay, they need to have the timing right. They can tell where the developing queens are, or the princesses, where they are in their developmental stage in the pupa, and they can also tell what the weather is like outside. So they have insight into both worlds. When both the developing queens are ready to hatch and the outside temperature is just right, the scouts burst into action. Okay? The scout bees will scramble all on their very calm sisters, and every few seconds they'll press their abdomens against the quiet bees and start activating their flight muscles to produce a 200 to 250 hertz vibration that lasts for a second or so. And this is called worker piping and sounds like the high frequency engine of a Formula One race car. It signals the time to get ready. Get their muscles ready for flying, warm their temperatures up to 35 degrees Celsius. Over the next hour or so, more and more scout bees pipe out the message, get ready, get set, at which point a second signal is sent out, a buzz run, in which each scout bee runs about the nest with great excitement, zigzagging. Well, think of a bull in a china shop. I mean, I've never seen one in a china shop, but think of a bull in a china shop ramming these bees through and waking them up. Keep on warming up, and it's time to go. So it's called, this sound is again very different, but the excitement builds. And then they go and they pour out of the entrance, and I've seen this a number of times, like a torrent of water. So if you're thinking of water running down a hill, they literally pour out the front, taking the mother queen with them. And they fly out into the bright sky and they swirl around and they dip, and the cloud can be about 10 to 20 meters across. Now, I've chased a few of my swarms across my suburb, hoping to catch them or at least find where they land. But there is a lot of noise, a lot of excitement, a lot of anticipation. You can hear it inside your house. And certainly for a beekeeper, standing in the middle of the swarm is an incredibly thrilling experience, and one that I feel very safe within. But the bees don't go far, okay? So they're in the air, and sometime soon the bees will settle on a branch, usually about 10 to 20 meters away, and the queen joins them. And for the next 20 minutes or so, the bees will settle together in a clustered shape of the swarm. So when I get calls coming in from people, they'll say, I've got a swarm of bees in my backyard. I often ask them to send me a photo, and they're generally in a cluster, okay? So this is just an intermediate sort of stop-off point or a resting point. Think of a petrol station, a pit stop. Now the question I ask you, raise your hand if you can see the queen on the outside of the swarm here. Can you see her anywhere? Okay, if you have a look very carefully to your left-hand side of the screen, you'll see this brighter yellow abdomen, quite long. That's the queen there. Okay, generally she's on the inside of the swarm, but here she's just decided to crawl on the outside. She always is protected within the inside. So the bees will remain on a tree or similar object for several hours or several days as the scouts now go and look for a new home, a more permanent home, and they need to hurry. The provisions of the journey are limited, so we know that they've gorged themselves on honey. And as you can see on the image here, a storm can devastate an unprotected swarm hanging from a tree. And I've come across this as well. And here the swarm just doesn't survive. And I think I may see the queen at the top there as well. So bees are attracted by the scent of their mother queen. It's a strong lemony smell. Okay, this is the attraction pheromone that's first released, firstly by the settlers. And then, as you can see on this case, I had to catch some bees or catch a swarm in the city. But it's also the queen that has that scent. And the pheromone, again, is released by a Nasanov gland located at the tip of their abdomen. And they open that Nasanov gland out and start fanning their wings to disperse that smell into the air so that all the other bees can join that cluster. So if you do find a honeybee swarm that looks like this, please call a beekeeper who will come and rescue it. Don't spray it with water. Don't smoke it out in any way. The queen won't fly away. They won't fly away. They want to protect their mother queen. Remain calm, be patient, and do take time to watch the bees. And especially that amazing little scout bee, because it's there. It's on the surface there. They are there, and you can see them performing their waggle dance on the surface of the swarm. So let's find out about these amazing scout bees. What role do they play in helping the swarm now move from this site to a nice hollow in a tree? So the swarm relies on its scout bees to find this new dwelling place, and they do this by performing a waggle dance on the outside, on the surface of the swarm. Each scout bee is trying to convince her sisters that the new site that she's found is the best. So let's say we've got 10 scout bees. Each scout bee's gone out and about and investigated someone's air vent, compost bin, cupboard that's been left on the outside backyard porch, anywhere. They will come and they'll start performing their waggle dance. The more vigorous the waggle dance, the more likely the scout bee will be followed by some of her sisters to, that compost bin or that wine barrel, and they'll want to investigate that site. The waggle dance is a really complex process, and it was first discovered by a professor of zoology at the University of Munich, Karl von Frisch, and he made a revolutionary discovery for which he would eventually receive the Nobel Prize. That an insect, the worker bee, communicates to its hive mates through dance. We call this the waggle dance. The term dance floor was coined by Jürgen Tolz in his book, The Buzz About Bees, and I've presented a bit about the book in the previous episode. And he talks about this dance floor as where this waggle dance takes place on the comb. So it can occur both on the comb and on the surface of a swarm. And we'll come back to this dance floor again a little bit more in episode 3. So the waggle dance, just as an introduction, is a pattern of bee movement dancing on a vertical surface. It's not on a horizontal surface. The angle of the waggle dance is relevant to straight up on the vertical surface and represents the angle of the outward journey relative to the direction of the sun. And the duration of the waggle dance is proportional to the length of the outbound flight. So what's really amazing is that the bees that follow another bee's waggle dance are actually able to decipher her dance and put her instructions into action, either in terms of finding the new dwelling site or finding floral sources for nectar and pollen. So here's an example, and this is taken from Thomas Seeley's book. Let's say at 10 o'clock, 2 scout bees discover 2 different sites. The tree on the left has a really nice hole opening. The tree on the right has a nice smaller opening. The smaller opening is much more desirable, much more insulated, and less exposed to colder temperatures. And each scout then returns to the swarm and performs a waggle dance for her site. But the scout in blue from the right tree performs 3 times as many waggle dance circuits as the scout in red from the left tree. The result is that 3 hours later, the number of bees committed to the right tree has increased 6-fold. Compared to the number of bees who support the left tree scout bee, that's only increased 2-fold. After 3 hours, the numbers of scouts for the right tree has increased dramatically, and this is how the scout bees achieve consensus. It's almost like a democratic vote. By convincing her sisters through the vigor of her dancing, this is the favourite site. And then they will take more bees to have a look at the site. And once that's been agreed upon, it initiates the second stage of swarming. Again, the bees need to warm up. They are now aware that they're having a dwindling honey reserve. So their crops are getting less and less, and they need that honey for fuel. And over the next hour or so, more and more scout bees pipe out the message to get ready. Again, a second signal is sent out in a buzz run where the bees charge through the swarm, zigzagging across the surface, buzzing, let's get ready, we've got to go. And then the same process applies here. They take off, and the bees take off again in a swirling mass. The question is, how do all these bees, 10 to 20,000 bees, know where to go? How do you steer something this big? Again, this is where the scout bees come in, and they're called streaker bees. Now, they're not naked running across an oval. They're called streaker bees because their role is to start directing the swarm, and they do this by flying. So the swarm is here, and they fly on the surface of the swarm, and they streak forward. The swarm follows, and then they slowly go back through the swarm. And they keep on streaking forward, darting across the surface of the swarm to keep directing all these 10 to 20,000 bees to the new hollow of a tree. Obviously, when the swarm bees go out to check out the hollow, you might have 10 to 50 scout bees. You can't have 10 to 20,000 bees always flying to check out new sites because the reserves keep on getting dwindled more and more. And once they land at a new site, again, the pheromone, the citrus-scented pheromone is released from their nasonoid glands, and it signals the bees to come and land. And the excitement is actually quite visible and palpable. There's a lot of dancing and running around and excitement that you can see from the bees, and they enter that cavity very, very quickly. The whole swarming process is really, I term it a beautiful experience because it is something so lovely. So if you do see a honeybee swarming in your garden, welcome it to your garden. There is folklore about talking to the bees. Call me, call a beekeeper, and we'll safely remove it. And do remain calm and patient. They're not out to get you. They're there as an intermittent stage, wanting to protect their queen. And again, before springtime, do close your house air vents. Any cavities that you could see there's a potential for bees to get into, just close that off so that we don't have to euthanize those bees. So I thank you. These are the references that I used for my presentation today, and I look forward very much to talking to you next week. Thank you so much.
Hello, everyone. That was fantastic, Sandra. Very good. I have some questions. So some questions came through the chat and some questions came through the Q&A panel. So I'll start off with the Q&A panel. We have one from Nellie. Thank you, Nellie. She says, thank you, Sandra and Mark. Fascinating information. When bees are swarming, are they pretty harmless to people? And should we just stay away from them until they move on?
That's right. So bees, you can stand in the middle of a swarm and they're not going to, come to get you. Just leave them alone, let them settle. Ideally, it's best to call a beekeeper when they've settled, because if you call a beekeeper, they'll say, well, actually, I'll come, but they need to actually settle. Then I can remove them. So they won't come after you. They, unless you're aggressive towards them. Yeah.
Great. Now, I have another question from the chat. One is from Kate. She says, is this session available to be later, as is the first session? We'll be putting all of these recordings up online eventually once the process is finished. So anyone who's interested will contact you via email to let you know. And then we have another one here from Laurie. Can swarming bees cross over between swarms, and are they welcomed by their new home?
Okay, so you could have 2 or 3 swarms that merge. So say I've got 5 beehives in a row, 2 of them decide to swarm simultaneously. There would be a little bit of confusion there, and it's, with the larger beekeeping apiaries, it's not uncommon to see swarms that are 3 meters in size, because the bees just have suddenly said, right, we've got the pheromone everywhere, we're getting confused, and you'll have a coming together of swarms. I've also caught a swarm where there have been 2 queens in there. And so there's no hostility that's shown between the bees to one another, or the queens to one another. And I've just caught them and put them into one hive. So
that's great. And we've had a nice comment from Nikki saying, this is fascinating, thank you, which is very nice.
My pleasure.
And there's another one.
And from Nellie again, how are scout bees selected?
How are scout bees?
Yes, how are they selected?
I think so. Scout bees live for 5 weeks. 3 weeks of their life, they're inside the hive, inside the nest. The final 2 weeks, they're outside as foraging bees. So scout bees need to be in that last 2 weeks of their life cycle, so that they have knowledge of all facets of their role, and they specifically need to have knowledge of the outside environment as well. So generally, there are bees that are in the last 2 weeks of their life, and how they're selected, I think that's still the wonderful mystery of bees and beekeeping. I hope we never know everything, so I can't answer that question.
We have a professional question here. What makes bees angry and chase people and dogs? I've been dealing with a job regarding bees. It was reported the neighbours' bees were doing this.
Okay, so bees are like human beings. They have personalities. Each colony has a different personality, and that personality, like ours, is influenced by this cold day today with the rain that's making some people slightly grumpier than others, humidity, thunderstorms. If bees are hungry, if they're queenless, if they've lost their mother, bees become quite unsettled, protective, worried. If their queen is out on a mating flight, where a queen hatches, obviously she needs to have a little bit of fun in the sky. They get quite agitated in the hopes that she comes back successfully. So there are a number of things that bees pick up on that make them aggressive. And it can also be genetics as well. Some bees have more of a highly protective instinct than others. And if they feel threatened. But generally it's either hunger, or if people get stung and you just happen to be in that bee's flight path and they whack against you. And, you weren't there before, but now you're there. And that's often when stinging.
You're suddenly in the way.
Yeah.
Gotcha. Now we've got just a couple more minutes. We're a little bit over time, but I think people are still happy to stay with us. What proportion of bees leave the original hive, and do we know how they decide which bees go to the new site? That's from Amy.
About a third leave the hive, and there needs to be a variety of age groups. So you don't just want the bees that are in the last 2 weeks of life. You want also those bees that are the nurse bees, the undertaker bees, the air conditioner bees, the heater bees. You want a good variety of bees to come with to establish the new colony.
You want half your workforce to come with you and start a new life, basically, don't you? Not the dud bees. Okay, another question from Sophie. Is it the old queen that swarms, or one of the new reared queens, and what happens to the other reared queens and the old queen?
So it's the old queen, the mother queen, that swarms. And what happens to the other queens? They will all hatch. So previously I said, let's say there are 10 there. They will hatch and fight to the death. So if the first one hatches, she will go around to all the other unhatched queens and sting them to death. If 2 hatch, they will fight and all the bees will circle, and they'll want the strongest to survive. I'd want the strongest to survive. So they want a pristine queen. And then that surviving queen, fortunately they just have one, then has to go on a mating flight and come back without being eaten or disappearing for some reason, because when that happens, the hive has a problem.
Sandra, we have a related question. When does a queen bee stop being the queen of the hive? I understand that the queen will move on after the 10 eggs have been laid, but how many times does this process of swarming continue for one queen? That's from Anders.
Look, she can swarm every year. So you have that one queen. She's the mother queen. She swarmed with a third of her colony has come with her. They settle into a hollow of a tree. Come next spring, you've got too many bees, too much honey there, it's congestion. That old queen, if she's still alive and if they haven't superseded her, she will then head off again. And as bees, a queen can live up to 5 years, so she can be on the go a fair bit. Yeah.
So she's busy.
She's a busy girl, yeah.
Okay, one more question and then I think we'll wrap it up. My sister has a beehive in her garden. last year there was a very large swarm on her grapevine. Is it likely this her own hive or was attracted to her garden from elsewhere?
It could have come from her hive. If she has a hive, it's highly likely that it would have landed on there. It could have been from another hive. I don't know if there's any evidence to underpin this, but bees often attract bees. So when sometimes other bees that come in, a swarm, can scent that there's comb, brood, honey, pollen in the air. That might instill in them a sense of security, and they'll land where another colony currently exists.
But basically they can see that there's good neighbours there and all is good. That's why they want to move in. Okay, it's like being in a nice area. One more question. It's from Samantha. She says, what is the best way to provide a water source? A shallow container?
So the best way to provide a water source is to ensure that it's a continuous water source all year round. Shallow, bees don't have temperature. So if the water gets hot, they can't feel that heat, but with pebbles in there. And so that they can land on there and they don't drown in the water. And it's often quite funny to see them squabbling over who sits on what rock. So, a bird bath, water, but it must be a continuous water supply. Otherwise, the bees won't continue to orientate to that site. They prefer a continuous supply.
Okay, very last question and then we'll wrap it up. From Mel, how far will bees travel to swarm?
They can travel miles. They can travel kilometres across, the country. And you can see how with the distribution of the Western or European honeybee, you can see how they've spread across the globe because they can just travel for huge different distances. So, or they could just travel down the street. Yeah, path of least resistance.
Excellent. Thank you, Sandra, and thank you everyone for participating today. It's been really good to have your presence. Hopefully you've enjoyed it. As I said the other day, if you loved it, tell your friends and sign up for the next 2 webinars. And if you didn't like it, don't tell anyone about it. All right. Well, thanks, everyone. Appreciate you being here. And hopefully you can join us next time. We'll send you a follow-up survey through the means you registered because we really do want some feedback on how the whole process goes. Constructive, helpful, kind, gentle feedback would be awesome. Remember, we are not webinar experts. We're definitely webinar amateurs, but decided to see what we could provide in these unprecedented times. Okay, thanks everyone. Cheers.
Bye.